Hey class, this is your linear function review video. Okay, so I'm going to be using this data set from the function notes. There's five coordinate sets, 2 and 13 to 10 and 53. Our x values, our time, and that is in seconds. And our distance is our y value, and that is in feet. Okay, so y values are going to run on this y-axis. The x values are going to run on this x-axis right here. Let's go ahead and plot these five coordinate sets. I've gone ahead and done that. I created a chart, a graph for the chart that we have. Distance in feet, time in seconds. Our run goes this way, our rise goes this way. I've gone ahead and plotted 2 and 13, 3 and 18, going over 1, 2, 3, up to 18, going over 1, 2, up to 13. And I did all five 1, 2, 3, 4, 5 coordinate set pairs. I then use a ruler to do that linear function line. And because I was estimating a little bit for the feet distance, it's not perfect on that line, but then it crosses for the y-intercept over here. So later, when we solve for the y-intercept, it should be in this neighborhood, the value. Okay, so the first thing that we want to do, if we are generating a linear function equation from a data set, we need to calculate the slope. So slope equals rise over run. I went ahead and took any two coordinate sets, data sets. So I took the first two x and y's, x and 2 and 13, 3 and 18. So for the rise going up from 2 to 3, it went from 13 to 18 feet. So that is a rise of 5. 18 minus 13 gives you 5. For the run going to the right, it went from 2 to 3. So that went up a value of 1. 3 minus 2 equals 1. So your slope for this linear function is 5. 5 divided by 1 is 5. So we solve for the slope. Next thing we want to do, plug slope into y equals mx plus b equation with an x and y coordinate set from the data set. Well, I'm going to go ahead and take 2 and 13, just because I could take any set. I'm going to come down here. Here's y equals mx plus b. 13 is our y. 2 is our x. And our slope, m, is 5. So again, I'm using this linear function formula, y equals mx plus b. Our slope is here. This is the dependent y variable. Here's our independent x variable. And we're going to solve for the y-intercept. So 13 equals 5 times 2 plus b. 13 equals 10 plus b. Subtract 10 from both sides. To isolate b, b equals 3. So our y-intercept is b, which means that this line right here should cross around 3, which it does. If this is 10 and this is 0, this is 5, 3 is right in that neighborhood right there. So it makes sense. Our linear function line seems to be following the order of what we're doing. So our linear function is y equals 5x plus b. There's your slope. There's your y-intercept. Now to write it in function notation, we're just going to take that y and that x, and we're just going to give it some more appropriate lettering. Okay, so for distance, our y, I'm going to call this d. Okay, and for our x, I'm going to call this t for time. So to write in function notation, we would say distance is a function of time. Distance is a function of time in which 5 times time, should be a lowercase t there, plus 3 will give us our distance. So distance is dependent on time, in which 5 multiplied by the time plus 3 will give us our distance. So this is how to write in function notation. I just kind of talked it out, what it says. Distance is a function of time, in which 5 times the time plus 3 will give us our final distance value. Okay, interpret the slope. What does the slope mean? It's 5, and that means for every increase in x, it goes up 5. I want to kind of come back here and look again. For every increase in 1 in time, x, our slope will increase by 5. So every second that passes, 5 feet of distance is added on. So for every 1 second of time, 5 feet is increased in distance. Okay? That is interpreting the slope. Now we need to interpret the y-intercept. Well, the y-intercept is where the function line passes the y axis, which is at 0 for the x. So to interpret the y-intercept, you want to say that when x is 0, y is already at 3. That's what the y-intercept is saying to us. Where are we passing the y-axis? We're passing at 3, which is saying with 0 seconds, your distance is at 3 feet. That's how to interpret the y-intercept. Interpret the slope. For every increase in 1, you're going up in 5 and rise. For the y-intercept, when your x is at 2, 1, 0, at 0, the y-axis is crossed at 3. And that's what the y-intercept is telling you. Okay, so at this point, the last thing that you could do is use this function notation to solve for other kind of what-if scenarios, inferring about some answers. So what if it's a distance of 100? What is the time? So we'd want to plug in 100 for the distance. So we want to say 5 times time plus 3 equals 100. So we want to solve for time. What is time? Well, we want to subtract 3 from each side, get 97. 5 times t equals 97. Let's divide by 5. And what do we get? 97 divided by 5 equals t equals 19.4 seconds. Which means that for 100 feet distance to be achieved, it would take you 19.4 seconds to achieve that distance, whether it's running or you're racing a car or whatever it is. The other way to infer is to do the other way. What if we have the time? Let's infer about what the distance would be at that point. So for 20 seconds, I'm going to go ahead back here. Y equals 5t plus 3 for 20 seconds. So what is the distance going to be if we have 20 seconds for time? 5 times 20 is going to be 100. 100 plus 3, y equals 103. So, after 20 seconds, you would have a distance of 103 feet, which makes sense because at 19.4 feet, you're at 100 feet. So at 20 feet, you're going to be slightly more. And we just solved, you're going to be at 103 feet, so slightly more than 100 feet. Okay. So that's kind of your review video for functions. Let me know if you have any questions. Thank you.